Hello, everybody. My name is Bryce Adelstein Lelbach. I am the chair of the C++ Standard Committee's Library Evolution Working Group, and I work at NVIDIA on our HPC compiler team, and I also lead our standard library team at NVIDIA. So today I've got some of my colleagues from the Library Evolution leadership here with me to answer your questions about the standard library and the future of C++. So first I'm going to have everybody go around and introduce themselves, and then we'll get to your questions. Inbal, you want to go first?
Sure. Thank you, Bryce. My name is Inbal Levi. I'm the chair of National Body Israel. And I'm also participating in managing the mailing list for Library Evolution. I think I'm probably the most recent member that is latest joined. So I'm really enjoying this. Thank you.
All right, Fabio, you want to go next?
Yeah. Hi, I'm Fabio Fracassi. I'm a lecturer at Code University of Applied Science in Berlin. I'm the chair of the German national body, and together with Bryce, I'm now the vice chair of the Library Evolution Working Group.
Okay.
And Nevin, you want to go?
Sure. I'm Nevin Liber. I work at Argonne National Laboratory on the COCOS team. I'm also on the SIGL committee. And for C++ committee, I am the vice chair of the Library Evolution Incubator Group. I've been doing standardization for a decade now.
Okay, cool. All right, we don't seem to have any questions yet in the Q&A. So if you have any questions, go to the little Q&A box and go ahead and put them in there. I will start us all off with a question that almost always comes up in some way, shape, or form. What belongs in the standard library? Who wants to start? Nevin?
Sure. So I think things like common vocabulary types certainly belong. Things like interface types like string view and span belong in the standard library. Common containers like vectors certainly belong in there as well, because they're the kind of things most people need to use. Algorithms belong in there because, again, well, not everybody, jumps on board of algorithms. Eventually, most people do come around to using them as well. And so after that, it gets to much more debate about, whether something should be in the standard library or not. Does it have enough of an audience for us to standardize it? The downsides for standardizing things is it takes us a long time to change, and it's very hard for us to make corrections because we have to maintain 99% backwards compatibility. So we can't respond as fast as individuals we would like to.
Fabio or Inbal, you want to take a stab at it?
So I would be a fan of having lots and lots of stuff in the standard library. Simply, for example, for teachability, I teach young students, and it's always easier to teach something if it's standardized, because then I can count upon that being there, that every compiler supports it, and that I don't have to teach additional stuff outside of the language. That helps a lot. But on the other hand, it's also very difficult and time-consuming to standardize anything. So first, of course, the thing that we want to standardize should be stable. That means it's not likely that it changes over the next 10 years or so. If we have something like cryptography or so, which is likely that it needs lots of updates over the next 10 years, that's probably not a good candidate for standardization, even though it would be immensely useful to have it. Yeah, so that's kind of the trade-off you always have. But other than that, yeah, I totally agree with Nevin, like vocabulary types and generally also things that are very hard for users to get right. That's always a good point for standardization. or that's so trivial that everyone writes it and has their own variant. That's also a good candidate.
Yeah. Inbal?
Yeah. Sure. So I really, as I mentioned in the latest, I really, I think I was really a bit surprised about, how do you how do you think of what should be part of the standard, what standard can really do and not do when you and first of all, clearly, all the things that are important to the majority of C++ developers, this is an obvious answer, but it's not that, I think it's not that simple of an answer to, a simple topic to answer, because just like a few recent surveys, you'd think that some topics that people that don't use exceptions, you would think that that's something that doesn't happen a lot, but there's like over 50% of the developers, just as an example for a topic that, so I think really whatever that needs to be addressed for the majority of the developers, clearly. And because once you put something in a standard, you get the support of the whole community of C++.
For me, I think that it really comes down to what things cannot go anywhere else. So vocabulary types, it's really difficult for them to go anywhere else, because the whole idea of vocabulary types is that it's a common type that you can use across multiple different libraries. If 3 different libraries I use have a different string type, it's really painful for me to have to deal with all of them. And of course, there's some library features that require compiler support, or that are really just language features masquerading as library features. And so obviously those have to go in. And then there's a lot of things that are abstractions around the platform, where the only or the best provider of that implementation is the person who's providing your compiler. So things like threads, mutexes, et cetera. So we have a question that's sort of in that same on the same topic, which is, how do we prioritize making changes to the standard library? Does anybody want to take a stab at that first?
It's not easy, because everyone has their own priorities, yeah, we have a plan, a document that all of the committee has voted on to prioritize. So that came as a draft with writing down most of the priorities that everyone understood what we wanted to do. And then we voted that we actually are sticking to those priorities. But in the smaller, that's a very big and very coarse plan. But in details, we usually have also to come to a compromise there, and then we just look at the different papers we have, and if we have too many to fit in, then we prioritize them by voting which one has the higher priority.
Well, to be fair, we didn't do a good job on that in C++20. There's a bunch of libraries that got approved from Library Evolution that the library working group just ran out of time to get to. And not necessarily, in any priority order. It's just they ran out of time, so they didn't ship. And we know we need to get better at that.
And C++23 is, so we developed this plan for C++20, but it was later in the cycle. C++23 is the first standard where we've had this plan that has very concrete goals and deliverables in buckets of priorities of work, and also fits within our our train schedule. C++11 also sort of was feature driven. This isn't to suggest that, I'm not trying to suggest that us having a plan means we're feature driven. We're still schedule driven. But this is the first time we've really had a plan. And so I think that's it's really helped us focus for C++23. And we're actually next week in the Library Evolution weekly meeting, we're going to be talking a bit about how we can get better at prioritizing things. There's a few different systems that we can have for it. And one thing we're going to try to do going forward is make sure that every proposal, when we're reviewing it, that we also try to assign a priority to it, and we try to categorize it. Is it a bug fix? Is it a new feature, et cetera? But it's certainly something that we've had to learn to get better with, as interest in C++ has really exploded in the past few years, and as the committee has grown. We have a limited amount of things we can get done. We have to use our time very cautiously, and we have to learn how to say no to some things, and that's very hard. But we can't do all of the things.
And I would just love to add that I think the pandemic really had a role in helping reorganizing the facilities, or the way they prioritize, because I think that the new situation have actually affected what we can and can't do.
Yeah.
So.
One of the things that we're doing that I think has greatly helped us and will greatly help us going forward is, previously there was more or less one person that was running each one of the groups, and now we have multiple people. And in fact, Library Evolution has a group of sort of 8 core people that are either chairs or that are running the mailing list reviews. And we've also got things like our incubator system that we've been using to sort of help us develop new ideas and make sure that we use our time as efficiently as possible, and that we can review things.
Either to say no early or to get things in shape from the bigger groups.
All righty, let's take another question. Could we get const expert versions of standard math functions like square root, cosine, etc., so on? I assume they forward directly to their C versions at the moment. Is that the issue?
So what I've heard from this is usually the library working group pushes back on this, and the implementers push back on this because C owns those, not C++. So they tend to push back on making changes to C.
Yeah. So there's a fairly practical problem in the implementation space. Who can fiddle with the headers? Where do they belong? And they're not always in the same spaces, and not even always. Like sometimes they're just imported. So this is really fiddly. But like from a design perspective, we would like that.
Yeah.
There is a proposal for this that we've looked at recently. But one of the other issues is around the accuracy and precision guarantees that we can make. It might be surprising to you if your const expert sign function gives you a different result than your runtime sign function. And suppose that you're cross-compiling for some embedded chip. Then your compiler has to emulate the entire math environment of your target platform to be able to evaluate this function in the same way at const expert time. So there's a lot of challenges in providing these facilities, but it is something that's on our radar. All right, it's the top upvoted question, so I think I've got to do it next. Why isn't there much talk about executors at Cppcon this year? I'm not sure how well we'll be able to answer that. I mean, it's obviously something that is very popular topic on the committee. I can't speak as to why people aren't talking about it, but my guess would be that it's because all of the authors are busy trying to deliver executors to all of us.
We had a lot of telecons to talk about executors.
Yeah,
it's a higher priority thing on the plan.
Yeah, it's one of executors is one of the 4 things that we have as library objectives for C++ 23. I put them on the screen a minute ago, which is library support for coroutines, modular standard library, executors, and networking. And we've spent a large chunk of our summer looking at the executors proposal, and we formed small breakout groups that looked at different sections of it. And we're just now starting to look at the results of those breakout reviews and give the authors guidance for the next revision. So I think you'll hear a lot more about executors at the next 2 or 3 Cppcons. I think it's still got a chance that we'll be able to get it into C++ 23. Nothing's for certain, especially with the pandemic. But I think there will be a lot more excitement about it next year because I think we'll have finalized the design by then. And when I say that, I should say we'll finalize the design and worked out most of the details, and we'll be pretty confident about the exact shape that it'll take.
Yeah.
All right. Yeah, go ahead.
No, I just wanted to add that there's a lot of very good people working on that, and don't worry, it's on the table, definitely.
Yeah. Next question. One of the frustrations when using multiple compilers is the differences between STL implementations. Would it be possible to have a reference STL implementation used by all vendors?
Possible? I don't know. I'm not even sure licensing between different vendors would work.
I mean, we do see a lot more cooperation since now all of the major standard library implementations are open source, and there's been lots of common work. There's lots more talk between the developers too. Sometimes some libraries get sponsored or are incorporated in full, which should help. I don't see any vendor giving up their library anytime soon.
Yeah. One thing that we've started to see in the past few years is shared, is parts of the standard library being a shared implementation. For example, the parallel algorithms, GCC's standard library and Clang the standard library are using the same backend for them. And I believe my team has contributed implementations of the C++ 20 synchronization library facilities to both the Clang standard library and the Microsoft standard library, which the Microsoft standard library is now open source, and I believe it's under the same license as the Clang standard library. And one of the reasons that the developers did that was to make it easy to move code between the two. So there's some parts of standard library that are going to be specific to that platform or to the platforms and compilers that it supports. Things like type traits, et cetera, or things that interact with the OS. But some of the things that are more libraries that build on top of that, it's I think pretty feasible that you could have a single reference implementation. And in fact, there's a lot of people who want to have a bigger standard library in C++. And I think that this approach could be one way that we could get there. I tweeted the other day about this idea I've had for a while now, which is if we were able to get all of the major C++ compiler vendors together and to get them on board with the idea of creating a set of curated libraries that all the vendors would ship. There would be a single implementation of them. And there would be some lighter weight review process than what is involved for the IS. It would still be something that we do through the Standard C++ Foundation, maybe even through ISO. But to have some tier of libraries that comes with your C++ compiler that's not the standard library, not a specific implementation for each compiler, but a shared implementation. I think that might help us solve a lot of our a lot of the conflict that we have today between the folks who want a big standard library and who want a smaller standard library.
And we do get this, we talked about vocabulary types, but yeah, it still kind of assumes you have the same compiler chain for whatever you're running. Like, tuple under Clang and under lib C++, lib standard C++ are different. And they may be different sizes because they're doing different optimizations. And we know that that's friction.
Anybody else have anything else on this point or on this question, or we'll move on to the next one? All right. From an educational point of view, what are the most important concepts for using the standard library to get across first?
So I always like the parts that enable interoperability, like the vocabulary type, like string view, like span, like iterators. Those help to decouple the data types from the algorithms, and that helps a lot. And that's one of the key concepts I like to teach, because it helps in many ways to improve your coding.
Inbal, Nevin, any thoughts? Go ahead.
Sure. Go ahead.
No, it's okay. I just wanted to add that I think my favorite part is actually the type traits, because, it makes you, it's the reflection type part of this that makes, that I think that it have a very strong teachable foundation. And like, I think that I would love to have all the students learn that as an even quite a initial topic or second topic.
I mean, part of what makes standardizing hard is we know people copy what we do. Like the shape of containers, people base on the STL. And I think it's important that stuff get taught as well. But it makes our job very hard, because we have to, especially for new language features, we have to guess what's the best practice for using it.
I think the most important thing for people to understand about the design of the STL, really the key design concept behind the STL is separation of concerns. There are a bunch of related but independent components in the standard library, and when you add them together and combine them, what you get is more powerful than the sum of its parts. So one example of this, in the C++ standard library, algorithms are decoupled from containers. In some other languages, every container has a whole bunch of different, methods for various different algorithms. We tend to avoid that. We have very simple containers that provide iterator and range mechanisms to view their contents. And then decoupled from that, we have a set of algorithms that you can use those abstractions, iterators, and now ranges to apply those algorithms to your containers. And there's a bunch of other places where we have this too. Almost any time there's a customization point in the library, it's the same thing. We, instead of having each container have a bunch of different options for how it's going to allocate memory, we have allocators, which completely abstract the notion of memory allocation. So I think that's the key thing to understand about the standard library design, both as somebody who's using it and as somebody who's thinking about contributing to it, that often the best standard library components are the ones that are simple but compose with others. Yeah. And so one thing that I often think about when I'm reviewing something for the standard library is this particular piece of functionality really absolutely necessary, or is it something that some other abstraction can provide? How can we make this as small as possible to be a relate to the essence of this component, and then we can use other building blocks to combine with it to make something greater when you need it.
And people are really good at coming up with components, but our job is to make sure that all fits together into one coherent library.
Yeah.
And we're like, sometimes it's the most obvious way, or the one that people reach out for first, or things should be the default. We sometimes don't provide that. Like, we don't provide the easy default. We just give you like the Legos to build something on, the building blocks, and we fail to provide a nice facade for it. We could do better there, I feel, but it's also hard because we have so many users, and often when you ask people what is the obvious and what's the easy case, they disagree. They have totally different easy use cases that are totally obvious to them. So that's not always the same.
I'll give a concrete example of that. For mutable, for instance, some people believe that's for caching, and I tend to use it for things like mutexes because they're not part of the state of the object. It's alien part of the object. But they're both valid viewpoints. It's just, it depends on your experience what you're going to value.
No. Picking defaults that make everybody happy is very hard.
I think that one of the benefits of C++ is also one of the things that make it harder to teach, because it's very configurable, and because it's gives the developer huge freedom. But I think that once you grasp, the abilities, it's a very powerful tool. So
there's also, this happens a lot.
Keep learning.
On the language side, it's how consistent do we want to be? For instance, lambdas, the function call operator is a const member function that you would say mutable if you want to make it mutable, which is the exact opposite of everything else in the language. I mean, I believe that was the right call for lambdas, but we broke consistency by it, and it's just tough. These are, it's all trade-offs, and it's really tough making these decisions.
I think it's hard for people outside of the committee to understand just how much we care about consistency. There's two different types of legal. I like to use this analogy. There's two different types of legal systems. There's the French type legal systems, which are based on a very extensive, written down set of laws. And then there's the English system, which is based on case law and precedents. And the C++ standard library is by and large follows the English system of case law, that we don't necessarily have written down a concrete set of design guidelines and we say you must follow those rigidly. Instead, what we often do is we look at, well, what have we done in the past here? What decisions did we make in the past here? And if we make this decision now, will that be consistent with things that we did in the past? How can we ensure that we remain consistent? And when should we break consistency? So we often end up looking at, what have we done in the past when we're trying to figure out what makes sense to do going forward. All right, I got another question here. In my university C++ course in 2017, the standard library was not taught. Is this usually the case? Why do you think some professors avoid teaching the standard library? Fabio is probably the right person for this question.
I mean, it's hard. It's simply hard to keep on track. Building a course is a lot of work. And keeping up to date with new stuff is also much work. So if C++ is just one of the courses you teach, there's often very little time to do this. And if you have no other venues to keep up with it, and if you're not passionate about it, it's really almost impossible to do this if you don't shares. We have in the committee also now a working group, SG20, that deals with education, where we want to present guidelines how to teach, where we also build recommendations how to teach certain topics, in which order to teach certain topics, so that you can easier form a good curriculum. Yeah, education is one of C++'s big problem. If you if I teach my students, if I give them out, if they ask me for courses that they should do, because at our university, students learn very much self-driven, and we as teachers only help them when they have questions. And there are almost no good courses, like video courses, which most students nowadays prefer. There are almost no good video courses out there that are free. There are a few ones I can recommend personally, which I know that are good, but most of them are paid for. And most of the free ones teach questionable C++. So that is a real problem. And the same with tutorials and stuff like that. So yeah, we have lots of work to do there. And yeah, as study group 20 is very happy for help there. And this one you can join easily.
All right, next question. What parts of the standard library are the most misunderstood or misused? What do we think? There's so many options, right?
Yeah.
Valorate. No, I don't use Valorate, so I can't actually comment on that.
Yeah, that's what I'm thinking. Like most of the ones that come to mind are not that much in use.
Yeah.
Or
I think I would say string, because, and I think it's largely our fault and historical. Very often when you write string in your code, you really wanted to put string view. I remember when I first got started with C++, the single biggest challenge that I had was, or the single biggest problem I encountered in my first 2 months of programming C++ was accidentally copying vectors and strings a billion times when I was passing them around between functions. So I think that's one of the it's something that's hard for newcomers. It's also hard for all skill levels.
Yeah, when StringView showed, when Jeffrey Askin first proposed with StringRef before it was called StringView, I looked at it and go, man, this solves my problems. Why didn't I think of it? Conceptually, it's very simple, but yeah, it was a need that,
and it's also an example, many people were very upset that C++ 17 didn't have so much nice things, that it wasn't so, that it wasn't such a huge release as others. And for me, it was great because with StringView, we have this really big vocabulary type, which changes so much of our code. You can make use of it easily. You can also, of course, you can backfill it, and you can use the library implementation of it. But now having it as a vocabulary and making everyone aware, everyone knows how to use it, and now libraries can also use it, that changes our interfaces immensely.
Well, I feel like we answered the opposite question, what's really useful instead of what's not very useful.
Yeah. I would also say that probably I think a lot of concurrency primitives are misused. I think people tend to be a bit too liberal with their use of mutexes in places where they could probably use atomics. And I realize that's a controversial view. But if you're doing concurrency, you may as well do it right. And while yes, atomics are more challenging to use correctly, I've seen a lot of code bases, including one I have to frequently deal with at work, that their primary performance problem is excessive use of mutexes, and people get afraid to correct overly conservative synchronization later because they think that perhaps some other part of the code base relies on the overly conservative synchronization. All right. Next, we have, what are the differences between LUG and LWG? What is the process for moving a proposal from one to the next?
Yeah, so basically, LEWG is a design group. We look at what we want to have and how exactly it should work. And LWG is the group that implements it in standardese, basically. We already look at the wording to see if the wording says what we designed. But then LWG makes sure that it fits with all of the other things, that it doesn't have any any problems in there, any incompatibilities with other stuff, things like that.
Yeah, and it's a fuzzy line between the two. And one of the things is a lot of implementers, standard library implementers, are spending their time in LWG. So a lot of the time, they'll either just push back or they'll just come, did we consider so-and-so? And it's not always clear from our, we have scribes that take wonderful notes, but that's also a hard job. And it's not always clear if we've actually, considered certain points that they find important.
Sorry, go ahead.
Yeah, the example we had before with the const per mass things, that's such an example where there's some tension then, because from the design perspective, it was clear, yes, it's useful to have those, seems simple enough, go for it, do it, wording seems simple too. And then LWG, where all the implementers sit, tells us, yeah, well, might be simple in the design space, but there's a few points you haven't considered, like what Bryce said before, like the accuracy problems, and that you have to re-implement everything for cross-compiling, things like that. So then there's pushback.
And this is one of the reasons why we place a lot of value in what we call field experience, which consists of really three parts. Implementation experience. Has somebody implemented this proposal?
As part of the standard library.
When you're doing it?
Yeah,
as part of the standard library. Yeah. And then there's usage experience. Has that implementation been used by people? Has it been used widely? What sort of feedback have we gotten? And then finally, there's deployment experience, which is, has it been used by people over long periods of time? Do we know what what will happen if we try to change parts of it? Can we change parts of it, or will that, break people in horrible ways? And so we often, we're looking for those sorts of things when we're reviewing proposals. And admittedly, we don't always have the amount of experience that we'd want, that we think we'd ideally want before we ship things. But oftentimes, it is impossible to get that experience until you've actually shipped it. There's only so much that we can do before,
especially for new language features, like for 17, like deduction guides. Right, no one had any field experience.
Yeah, that was probably a case. That's probably an example of a feature where we could have given it a bit more time, and we could have waited to have.
Sure, but I can, for 11, it was no accept. I mean, it was the final meetings where how we decided the Lycos rule, wide contracts, contracts with no preconditions that don't throw exceptions can be marked no accept. Where that all came from, because we needed some kind of guidance for how do we mark this up in the standard library that we're about to ship as part of C++11 at that meeting. We push lots of things off the library at the last minute, and it's hard. We're trying not to do that anymore.
Yeah, and actually,
you don't have the time to do it.
we have a new, one thing that's happened in the past 2 years, and especially in the past 6 to 8 months, is because of the growth in the committee and the growth in the number of proposals that we're receiving, we've made a lot of changes to how our process works. And one part of that is changing, how things flow between the groups. We've introduced these incubators, and there's a recent paper that lays out some new it's rules of design specification engagement. So how should LUG interact with LWG, and how can we make sure that we give the specification group enough time, and that we avoid late surprises. So we've added more process. And I think that's been a good thing. And then we've also, a lot of process changes have come about with the switch to virtual meetings. And I think that the result of this is that in future standards, I'm hopeful that we're going to have an even higher bar for quality, and that we'll have less surprises.
And to expand on virtual meetings, people who normally just sit in LWG have come to LEWG and vice versa. So we're getting the kind of cross-pollination that we just can't do at physical meetings because we have so much to get done, and we're running, 9 parallel sessions, I think? It's physical meetings.
And I would love to add about the process of the new proposal. So the first thing is that if the proposal is related to one of the things, to other study groups, then it would probably visit there. And later on we'll reach the incubator, as Bryce have mentioned. And I think that's a very important part. I'm really happy to be, part of that with quarantine. And there you're gonna get some feedback, some initial feedback for that idea. And later on, as Bryce have mentioned, the continuation of the progress would be to get the design worked out as part of LEWG, and then the wording as part of LWG. So I hope that makes sense.
One of the possibly bigger changes is I'm fairly confident that at least for the next year or so, almost all new proposals that aren't related to one of the big features are going to go through a mailing list review prior to any review at a telecon meeting or a face-to-face meeting. And Inbal is one of the ones who runs those mailing list reviews. We just don't have the processing bandwidth of telecons and even with face-to-face meetings to be able to handle all the papers. And so instead, we're increasingly relying on these lightweight, email reviews. And we might move to some, more modern platform like Discourse or something GitHub based for this. And this lets us get feedback to authors quicker. And for proposals that are in the first draft of the proposal, that's really all that they need. And I think this is also helping us get engagement from larger chunks of the committee on proposals. You might get somebody who during a face-to-face meeting would never look at your paper. They might, be able to look at it in the mailing list review. So I think that's going to become a increasingly important part of our process going forward.
And that process is also for committee members. It's not just like for, outside people who have more gates. If I make a proposal, I have to go through the incubators too. And subgroups. I expect to.
Let's see. Next, we got this one. What is the story for Async IO? As I understand, Async IO would come to the standard library after executors land.
Yeah, yes and no. It is already in the pipeline, and it's like it has some overlap, and so it's very important that once we finalize executors or almost finalize executors, before we standardize fully the networking proposal or the asynchronous I/O proposal. So because we need those building blocks, and we need them in a sufficiently stable form before we can build anything upon them.
Yeah, I think if I wrote down a 10-year plan for the standard library, maybe I do have a secret one written down. But if I wrote down a 10-year plan for the standard library, it would largely revolve around asynchrony and I/O. I think almost all of the things that we're doing or that we want to be doing, and almost all the parts of the standard library that really need a modernization relate to that. Executors is this basis that we're going to build almost everything else on top of. And there's networking, of course. There's a desire and there's some proposals to modernize file I/O. There's an async file I/O proposal. It's around time that we really had a proper replacement for I/O streams. And then the other component of that is Unicode, that almost all of our textual I/O facilities in the standard library today are not Unicode aware. And so we're going to need to introduce Unicode aware versions of them. And I imagine that a lot of those will be async friendly. So yeah, I think that's where we'll be delivering a lot of new features and a lot of value in the next few standards. All right, let me see if we can find, we're starting to get towards the end. Somebody asked, is there an example of something that has gone through the incubator? And I'm trying to think of a good or my favorite example. So here's a good example. And I'm not going to remember the paper number, but on the first day of the library incubator, we looked at a paper from Quarantine proposing some changes to the concepts for ranges to support move-only iterators, if I'm recalling this correctly. And we looked at it, we gave them some feedback, and we felt it was very important because it was the sort of thing that we would either do in C++20 or we wouldn't do at all. And so we sent it along. It was one of the only things that the incubator sent to Library Evolution for C++20, and it ended up getting into C++20. And I'm glad it did. I think it improved ranges overall.
I think Step Trace is the current one. I think that LWG just approved tentatively approved for 23. We haven't had an actual plenary vote, but
probably my favorite incubator paper right now is the process paper. It actually started at C++ Now. C++ Now used to do these library in a week things where we'd try to design a boost library in a week. And 1 or 2 years ago, I suggested, hey, let's do a committee proposal in a week. So a group of people got together and wrote a proposal to standardize essentially boost process. And it's a very well-written proposal. The authors are very responsive to feedback. It's been through the incubator a few times, and it's a really good example of how to do a paper properly and how to interact with the committee well, that they've, when they get feedback, they take it and really to heart, and they go and apply it. And it's very well written. There's also a proposal for a UUID library, which I kind of like. It's a small thing, but it's good. All righty. I think we can maybe do 1 or 2 more. There's a few fun ones I'll save for the last 5 minutes. There's a couple that we've sort of already addressed. What is the most helpful way I can provide feedback on which changes I believe should or should not be prioritized for the standard library?
I would think just send in the email, the mailing list, you know.
And the most important part there is give us reasons.
Yes.
If you just send a list and tell us this is the list, this is the priorities, this you have to do this, or otherwise I'm going to be sad. Well, that makes us sad too, but we really need good reasons so that we can see why it is important, and then that makes us see those reasons and then shepherd it along and prioritize things that should be prioritized.
Yeah, and the reasons that's really, I totally agree. That's what's important. That's what's important in design. I mean, reasons do convince committee members to change their opinions.
Yeah.
Just saying you don't like something, okay, but that's not enough information for us to go on.
This is also the best way to get involved in the committee. I originally got involved in the committee. I had known about the committee for a while. I did a lot of stuff at C++ conferences, but the way I got involved was there was one particular paper that was in a subject area that it was very relevant to the work I was doing at the time. It was a early version it was a paper proposing something similar to MDSpan. And I had some, thoughts and feedbacks and suggestions for the author. And so I reached out to them. I sent them an email with, a bunch of feedback, and I chatted with them a little bit. And then they suggested that I should go to a committee meeting. I think the best way to have your voice heard and to get involved in the committee is to go and provide feedback on, some existing proposal. Some people think the best way is to propose a new thing. We have many new things. The new things create work for us, whereas providing review and feedback does work for us. So if you are somebody who's not on the committee and you want to get started, I think the way you do that is first you go and you find something that you have an opinion on, some proposal, or, if you have opinions on the set of priorities for things, and then, write up your opinions in some way, shape, or form. It doesn't have to look in its first draft like a committee paper. Just provide some write-up. And then I would reach out to, any of us library chairs or to the proposal authors. All papers are supposed to have the email of the contact person for the paper, and send us those thoughts. And then we can help you, get that feedback in front of the right people. We can help you even take that feedback and turn it into a paper. Sometimes we'll have papers that are not actually proposals in themselves, but are feedback on other papers. And then we can sort of use that as a way to onboard you into getting more involved.
I mean, our goal really is no surprises. We want more information, especially things we may not have thought about. It is important, and that includes prioritization of the stuff we do.
Yeah.
Yeah, and I would recommend also, of course, read proposals. Just it's not a condition to you can just focus on one proposal, but I would recommend, just to get the hunch, get the feeling of how things are done, and get more familiar with different topics that are the top priority now or are being discussed, and even, get some information about how a certain proposal was considered. I think it's a very interesting process in general, and it's good to get familiar with it.
In many ways, it's very similar to what you would do if you wanted to get involved in a large open source project. That the first step is that you want to build, you want to build some expertise yourself, and you want to build some record of contributing to that project in some way. And as you start making some contributions, you'll get more and more involved in that community, and then you'll have more and more of an opportunity to provide your input. So I guess essentially what I'm saying is the best way, like if you want to help set the priorities for what should go into C++, the best thing is ultimately to get yourself in a trajectory to join the committee. We do have some ways of getting data and input from the community, like the standard foundations surveys that we do 2 or 3 times a year, like putting your feed. The entire committee gets the results of that survey. But that's nowhere near as valuable as having a person that's on the committee that we can actually talk to and that can express their opinion. Like that's very helpful.
Yeah, and I would just love to add that I'm also, it's like, at least the way I see it, it's very important to me personally to collect data, to collect input. So feel free to just email me with thoughts, or I really think it's like the standard is, first of all, is for the community. So
all right, we'll do some of the fun questions now. Does Bryce get tired of getting grief from people in the groups that he chairs? And this question is asked by one of the people who's one of the other Library Evolution leadership.
Absolutely, no, giving him grief.
I would say I don't get. It's not the grief that I get from the Library Evolution people. It's the grief that I get from JF and Hannah that gets to me. And then where, Nevin, did you get the Cppcon Chef Hat?
So for the first Cppcon, I suggested to John Kell we do building the C++ committee. So I gave myself $100 budget to have this made. I got the real logo, and then it's only like $30. I ended up getting I have the whole chef's outfit for it too. So this is one of a kind.
I have to say, on any of the committee Zoom calls, Nevin always has a great background, and it's always something different that it brings joy to my heart. All right, and then let's close on this question. What features are you most excited about that are in progress? So let's go around and do that, and let's start with Inbal.
Sure. So I think I'm a bit, executors, I think, are the most interesting thing that's going on right now. I mean, I really think that this is like a great use case of how do you design something that is trying to help everyone and have different needs, different constraints. And I think it's fascinating, just to see that in action. I'm very excited about it.
Nevin, how about you?
It would be a language, it would be pattern matching, because for me that makes variant much more usable. And I think we really need that.
Yeah.
Fabio, how about you?
Yeah, I can second what Nevin just said. I am also very excited about pattern matching, even if it's not a library feature. On the library side, probably, and that's something that already left LEWG function ref is pretty interesting.
Yeah, I was thinking about any invocable, mostly because it's missed the last 2 standards just barely, and it's time. It deserves it. That's just a type erasing wrapper for it's an improved version of std function.
Right, it's a move only version.
Yeah, and I would say, I think the thing that I'm probably most excited for is the continued expansion of what is capable in constexpr and reflection. Reflection is a technology that's going to enable a lot of other library technologies for us. Yes. For example, we during the fireside chat earlier in Cppcon, a logging library came up. Somebody was like, "Oh yeah, a logging library. If we had reflection, we'd be able to build a really good one." There's just so many different libraries that will benefit from that. Obviously, I'm excited about executors. I'm corporately obligated to be excited about executors. Yeah. In terms of C++ as a whole, I think the possibilities that modules have and the possibilities of us doing a better job at enabling package ecosystems are probably the best thing that we can do for C++ in the long term. All right, well, we are at the end of our time. I want to thank all of my panelists and all of you for the great questions. And if you have any other questions, just feel free to send us emails or tweet at us or ping us on Slack. We're all fairly accessible.
Yeah.
All right, thank you all.
Bye-bye.
Thank you.
Bye, everyone.
Thank you,
Bye.
everyone.